Thanks for coming. Well, we're super excited, obviously, at SpaceX to announce some of the details around the Falcon Heavy rocket, which is our large rocket development, really large rocket development. This is something we've alluded to in the past, but I've only just recently completed the design and have been able to increase the thrust and payload capability of the rocket considerably over our previous estimations. With Falcon Heavy, we'll be able to put basically well over 100,000 pounds into orbit. In fact, it's looking like at least on the order of 117,000 pounds, maybe even above 120,000 pounds, depending upon what the final performance numbers look like. This is a rocket of truly huge scale. As we mentioned in the press release, this is the 117,000 pounds is more than a fully loaded Boeing 737 with 136 passengers, luggage, and fuel in orbit. So that is really humongous. It's more payload capability than any vehicle in history apart from the Saturn V, and so opens up a range of possibilities for government and commercial customers that simply aren't present with the current lifting capacity. If you compare our lifting capacity to, say, the Space Shuttle or the Delta IV Heavy, which are the two most capable vehicles in the world today, we're more than twice the payload capability of those vehicles. Although the Space Shuttle is obviously retiring this year, I think this is something America can be really proud of, the fact that there's actually going to be a vehicle with twice the capability of the Space Shuttle that's going to be ready to launch at the end of next year. The initial launch will take place from Vandenberg Air Force Base in California, where we have Space Launch Complex 4, but shortly thereafter we expect to be launching from Cape Canaveral as well. So we will certainly have that capability on both coasts, and we expect to be launching Falcon Heavy a lot, actually. Whereas Falcon 9 can address about half the market, Falcon Heavy can address the other half of the market, which is the largest government commercial satellites, as I mentioned, as well as opening up new market opportunities for satellites and spacecraft that simply cannot be carried to space by the currently available rockets. So I'd expect to see potentially new opportunities arising because of Falcon Heavy. Also, from a cost standpoint, which is critically important in space, because costs have been steadily rising, launch costs have been steadily rising over the years. Falcon Heavy represents a huge economic advantage. Falcon Heavy costs about a third as much per flight as a Delta IV Heavy, but carries twice as much payload to orbit. So it's effectively a six-fold improvement in the cost per pound to orbit. In fact, Falcon Heavy sets a new world record for the cost per pound to orbit of around about $1,000. So that's a pretty huge leap in capability. Yeah, let's show the video. So in addition to representing a new world record in cost per pound to orbit, the Falcon 9 is also designed to meet the NASA human rating standards. So, for example, it is designed to to handle with structural safety margins that are 40% above the actual flight loads that it expects to encounter, as opposed to the normal satellite launches, which are designed to only 25% above the flight loads. It also has engine out capability, so you can lose multiple engines on the vehicle and still complete the mission. It has cross-feed between the cores, which is the first time any rocket has been able to cross-feed propellant between the cores. And a triple redundant avionics. And all of this is such that it can launch people if need be and do so safely. Also, it has so much capability, so much more capability than any other vehicle that I think we can start to realistically contemplate missions like a Mars sample return, which requires a tremendous amount of lift capability, because you've got to send a lander to Mars that still has enough propellant to return to Earth. If you try to do a mission like that with a smaller vehicle, you have to send do several launches and either do orbital rendezvous or do some sort of much more complex mission. Whereas with Falcon Heavy, you could potentially do it with a single flight. Yeah, I think that's. Let me turn it over to questions.
Seth Warrenstein, Associated Press.
Hi.
Since you mentioned it, how much weight could you take? How much mass can you take to Mars or to a lunar in orbit? And in terms of what more has to be done to make this, well, you're saying it's designed to meet human rating standards. What more has to be done to make this NASA acceptable to NASA and to others, and for commercial customers to be human rating?
Sure. So the payload to Mars would be about a quarter of its payload to LEO. So we're talking about perhaps something like 30,000 pounds to trans-Mars injection.
And to the moon?
To the moon, it'll be about maybe 30 to 35% of that. So it's sort of maybe 35,000 pounds.
And so what more to make this, as you said,
right,
to make this more acceptable for human rating, and are you looking at using this? Is this efficient to be used for space tourism or other human rated things, or is that more fall to the regular Falcon? I mean, where does this fall in this?
Sure. Well, the Falcon 9 is suitable for transporting people to low Earth orbit, like to the space station and back. But Falcon 9 doesn't quite have the lifting power to go beyond the space station, whereas Falcon Heavy could go really much further than low Earth orbit. Falcon Heavy is about half the lifting capability of a Saturn V. So in principle, you could do another mission to the moon just by doing 2 launches of a Falcon Heavy. Perhaps one that delivered the return vehicle to the surface of the moon and one that delivered the lander to the surface of the moon. As far as we're designing, as far as human standards are concerned, Falcon 9 is designed to, Falcon Heavy and Falcon 9, I should say, are designed to meet all of the published NASA human rating standards. So it would only be if there's some unpublished standard or some new standard that's adopted that it would not be in compliance.
So do you, I guess that comes back to, do you plan to launch, how soon, do you plan to launch people on Falcon Heavy compared to, I know Falcon 9 is only a few years.
Yeah, Falcon 9, we always said would be about 3 years from when we receive NASA funding to conduct a demonstration. And the gating factor on that is actually not the rocket, but the launch escape system on the spacecraft. So Falcon Heavy would be, really capable of launching people. I think as soon as we've proven it out with a few launches, really, there's no changes that we are aware of that we would make to Falcon Heavy that would be required to launch people. there may be changes to the spacecraft that it carries, but not to the launch vehicle itself. Or if they are, they're very minor. So yeah, it certainly opens up a wide range of possibilities, such as returning to the moon, and conceivably even going to Mars, although it would require probably twice as many launches as a moon mission.
Frank Warren with Aviation Week. Two questions. On your engine upgrade, is this the same upgrade that you're doing to meet the SES requirement for commercial satellites?
Yes.
Okay. And can you elaborate a little bit on that? And then also, who is your first, or what is your first payload?
Sure. So we have an upgrade in the works for our Merlin engine, going from 95,000 pounds of sea level thrust to 140,000 pounds of sea level thrust. So it's a pretty substantial upgrade. And we're also making some design improvements to improve the manufacturability so we can go to a high rate of engine production. We're anticipating, if launch demand ends up being like we think it is, we'll have a production rate of about 400 booster engines a year, which I think would be more engines than the rest of world production combined. As it is, we're already more than the rest of U.S. production combined, although that's not saying much, unfortunately.
Your first payload?
We do not have, we're expecting to do an initial demonstration flight of Falcon Heavy that doesn't have a primary customer, although that could change. It'll probably have some smaller secondary satellites on board. However, we are highly confident of being able to, of announcing customers for Falcon Heavy for the second and subsequent flights. And we're in late-stage discussions with both government and commercial customers in that regard.
Are you looking at a Spelda-type device, something that can launch more than one satellite at a time, given the capacity to lift?
Yeah. Well, we actually, even on Falcon 9, have been launching secondary satellites. We launched some secondary satellites on the last flight of Falcon 9. With the upcoming flight of Falcon 9, the first one that's going to the space station, that will carry a couple of Orbcomm satellites. So with most missions, we expect to be launching secondary satellites. It's not always with the same dispenser, although that would make it a lot more convenient. But I think there's likely that most of our flights will carry secondary satellites. Hey.
Kind of more of a local question. How many jobs do you expect to be created by this new rocket succeeds, and how soon will they be available, and where will they be?
Well, I think you should definitely count on Falcon Heavy being there for the long term. So I'd say it's when it succeeds, and certainly hopefully that is right from the initial launch as it was with Falcon 9. We're starting off at Vandenberg, but they will then be transitioning to the Cape. We'll be upgrading a launch pad at Cape Canaveral so you can process both a Falcon 9 and a Falcon Heavy simultaneously, and they can both roll to the pad. We're also investigating the possibility at the Cape of using one of the old shuttle pads for Falcon Heavy. That's a possibility, but our default plan is to use our existing launch pad, but upgrade it such that there's a hangar where you can process Falcon 9 that rolls to the pad, and another hangar kind of at 90 degrees where you can process Falcon Heavy, and either one of them can roll to the pad, so you can have dual processing take place. In terms of the number of jobs, it really depends on the launch rate, so I'd expect that number to grow over time. But I think once it really gets going, and we do expect more launches to occur from the Cape than from Vandenberg in the long haul with Falcon Heavy, because of most of our commercial customers want to go to GTO, which obviously leads to Cape launches. So we're expecting probably a couple hundred jobs.
And by when would this couple hundred jobs? So we're talking early 2013, 2014?
It depends on customer demand. So I'd say it's probably 2 to 3 years, but it really depends on what the customer adoption rate is. I think I'm confident of a couple hundred jobs when the customer adoption is high, when we're doing several launches a year. I mean, I think we'll probably do as many Falcon Heavy launches as we do Falcon 9 launches. I mean, our rough ballpark estimate is something in the order of 20 launches a year, of which roughly half are Falcon Heavy, roughly half are Falcon 9. And of those, probably 60% to 70% are going out. I think there's a lot of wishful thinking on the part of our competitors that our prices must really be higher, but they are not. In fact, I think we're unique in the launch business in publishing our prices on our website, whereas other launch providers sort of treat it like a rug bazaar. It's sort of they'll charge you what they think you can afford. We believe in sort of everyday low prices. And we've stuck to our guns on that. So the Falcon 9 costs $50 million, and it's been that way for a while. And the Falcon Heavy is on average about $100 million. And we're very, very confident of being able to maintain those prices. And I'd say let history be the judge. Here I am saying it. We'll see if that remains true. But you have it on camera. Yeah.
NASA's very interested. I'm not sure you mentioned that. NASA's very interested in the round trip and mission asteroid.
Sure.
And one of the mission plans involved 90% of the total cost is 46 tons of space.
46 tons, okay. So escape velocity is zero. That's a zero C3, or is that what's meant by escape velocity? C2, sorry.
Zero beyond the Earth.
Yeah, escape velocity is like this. It's sort of generally thought of in something called units of C3. Well, let's see. We could do. Probably in the order of, I think with it's a bit of a stretch, but you might be able to do it with two Falcon Heavies. Kind of depends on what kind of velocity you're really looking for, and whether the spacecraft that you're launching has some delta V capability.
I mean, that's just how they spec the mission.
Right. Well, let me put it this way. I'm confident you could do such a mission with two Falcon Heavies.
It's actually easy to get to the moon.
Oh, if it's easy to get to the moon, yeah. I mean, if you had a sort of a small enough spacecraft, you could conceivably do it with one Falcon Heavy. It kind of depends on how big of a spacecraft and how many people you want to send. But I think you could slim it down to just do it on one Falcon Heavy.
It's pretty bare bones. It's two people. Much of that is for provision, food.
Okay.
They say 46 tons. I wouldn't count on getting it less than that.
I'm sure you could do it with two Falcon Heavy launches. If your spacecraft had a little bit of propellant on board, which presumably it does because it's got to get back from the asteroid too, then I think you could do it with two Falcon Heavy launches. I think we've thought a lot about going public. Before we do so, we want to make sure that we have a very predictable revenue stream, because the public markets don't like surprises. But I think that there's a decent chance we'll look at going public towards the end of next year. Not saying we will, but it's a possibility. It's possible, that we could see acquisition interest, but I have no interest in selling, and I am the controlling shareholder in the company. we've had some inquiries, but then I'm pretty clear with them that I would not, give up a controlling stake in the company because SpaceX has some, philosophical goals or philanthropic goals which may not be coincident with the goals of a large government contractor.
From Gary Bloomberg, what is the tentative date? Say by the end of next year. Do you have a month in mind?
I think at the end of next year, meaning November, December, is when we expect to have Falcon Heavy at the launch pad at Vandenberg.
And
The launch itself is a little more difficult to predict because we have to go through final regulatory approvals. There could be things that we have to debug about the rocket and launch site interaction. So I think most likely what you'll see is rocket at the pad towards the end of next year, and then a launch sometime in 2013. Well, I don't want to speak for specific customers, but I can say that there is strong interest from both the U.S. government and large commercial operators in Falcon Heavy, and that we are at an advanced stage of discussions with both. And part of what's needed to really get them to complete sign up to a launch is to not be the first. So it's always possible that a customer may jump in at the last minute and say, okay, they'll do it. But it's a lot easier to get deals done if customers know that they don't have to be the first flight. So it's a bit of a slight risk on our part to be doing the first launch on our own funds. And of course, it just costs us some money, but it's an important thing to do in order to get customers to sign up. We have to do something similar with Falcon 9. Right?
I'm curious about your production rates. That's basically 3 rockets right there.
It is.
Per launch. How many horsepower engines do you have on hand now, and how do you see that growing to get to the point where you can launch that and do your other business over the next year and a half?
So ramping up production is our number one focus. That's what I have the whole company focused on. And we're bringing in people both from the rocket industry as well as from other industries like automotive and high-volume aircraft production, because we'll be making more rocket engines than any company, actually more than any country, I think, has ever made. At 400 booster engines a year, like I said, 400 booster engines a year is more than the rest of world production combined. So that's pretty serious scale in the rocket business. And then in terms of the number of cores, we're talking about 40 cores. So it's very high volume, but that's what's needed in order to do 10 Falcon 9s and 10 Falcon Heavies in a given year. As it is, if you look at our launch manifest, we're just based on existing contracts that we have. If you go out 3 or 4 years, we already have on the order of 10 launches booked of Falcon 9. So, and we've only done 2 Falcon 9 launches, and we're only just putting a stake in the ground with Falcon Heavy. So, 20 launches a year is not a crazy number at all. We expect that to occur without any miracles, and so we must make sure that we are building our production capability and our launch capability to meet that demand.
Just 2 follow-ups. One, what's your starting point now in terms of those 2 types of hardware, cores and engines? And what's the job impact out there in California of ramping up the production?
Sure. So right now, our engine production rate is around 50 to 60 a year. That's what we can do with the Merlin 1C. The Merlin 1D, in addition to being a thrust upgrade and some performance upgrade, is really designed for manufacturability as well. And it's helpful that I have experience from the automotive world as well, And because in automotive, 400 engines a year is nothing. So there are a lot of techniques that the car industry has developed to be able to do high volume production, but also be very reliable and consistent in doing so. I'm very confident that with the Merlin-1D design, we'll be able to build 400 engines a year, or frankly, even 600 or 700 engines a year if we need to. And then the same with the cores. So we are making a significant investment in tooling and production process efficiency, honing our software systems within the company that manage the procurement and assembly and launch, trying to automate as much as possible. Nonetheless, we are expecting to hire a lot more people. And I mean, last year we grew quite dramatically, over 50% employee count growth last year. We went from 800 to 1,200 in 2010. This year, I think we'll probably grow 15 to 20%. And I'm actually intentionally slowing growth down a little bit just because I want to make sure we're building the company on the right foundation. And then next year, I expect the growth rate to continue to increase to maybe at the 30 to 40% level in personnel growth.
Just one more. Do you have the real estate and the supply chain to do that ramp up, or do you need new buildings and long lead items?
Yeah, we actually have been steadily acquiring the buildings around us in California, so we're sort of growing like the Borg. There's actually almost all the buildings around us have been acquired, and that's increased our capacity in California by about 50% in terms of real estate. But I think we can actually do a lot more with the existing physical locations we have. I really like density. I like a beehive of activity and people fairly close together. I think it creates a much better esprit de corps. And then you may have seen the announcement that in Texas we more than doubled the size of our rocket development facility in Texas, which is where we do development and acceptance testing of the rocket engines and stages. And that's in anticipation of a lot more growth. So we're now at over 600 acres in Texas. We're building up a launch site at Vandenberg, and we'll be enhancing a launch site at the Cape. So it's a lot of growth across the board.
I have one more internet question and maybe two more short questions from the floor, and then I think we'll get around to that.
Okay.
I was going to say, just to combine Todd's question, line of inquiry and Frank's, we've heard of the $1,000 per pound orbit.
It's the mythical number, right?
It is a mythical number. I mean,
That's not so mythical anymore.
So how much? I mean, it was sold on the space shuttle on volume.
Right.
They were going to do it on volume.
Right.
And it sounds like that's part here. If you do not launch 10 Falcon Heavies a year, if you are only launching 1 or 2 a year, will you still be at the 1,000 pounds to orbit, or is that only predicated on knowledge?
Good question. I think we'd need to launch maybe on the order of 4 per year to maintain those cost numbers. But I'm very confident that we'll be able to do that. That is, I think, not a tall order. And I think it's going to be a lot closer to 10 than 4. Also, because of the commonality between Falcon 9 and Falcon Heavy, we're able to spread the overhead across both vehicles. Because really, Falcon Heavy is essentially the upgraded Falcon 9 with 2 additional first stages of side boosters. So that it's able to use the same tooling, be made on the same line, and I think therefore significantly improves the probability of holding to our cost numbers on Falcon Heavy. But I mean, you're hearing it from me directly. It's being recorded that we will stick to those prices and not go above them, except for inflation and stuff like that. So in current year dollars, we will stick to what we've said.
Jessica Berman with Voice of America. Just a quick question. Would you describe for our listeners exactly what you're going to be doing in this first mission? You're achieving what you're doing.
Right. So the first mission is really a demonstration flight. It's there to prove that Falcon Heavy will work, that it will deliver the payload that we say it can. And we don't have a primary customer for it, but we're likely to have several smaller secondary satellites on board that will do a variety of things. And if we get lucky, maybe there'll be a big satellite at the last minute that wants to buy the flight at a reduced price.
Okay.
So.
And last question from my new class. She asked, is the Dragon going to be capable of going beyond low Earth orbit?
Yes. Well, Dragon is capable of re-entering from even Mars velocities, so lunar velocities, Mars velocities. It's a very capable vehicle, and is not limited to simply low Earth orbit operations. Can I be a little late for the next one, or what's the? I want to make sure I give. I know I've got to give a talk to a bunch of foreign policy guys actually for lunch, but I can probably arrive a little later in the lunch than yeah. So let me see. I'll try to answer as many questions as I can. At the back.
So could you lay out a scenario for us where you could use a Dragon and Falcon Heavy to do a lunar mission?
It's certainly possible to do a lunar flyby mission with Falcon Heavy and Dragon, so that where you sort of send a Dragon spacecraft on a loop around the backside of the moon. In order to land on the moon, there would need to be a propulsive landing system developed, which we do not currently have planned. It's certainly something we could potentially do, but there's no question that with Falcon Heavy and Dragon, you could do a really cool mission, which would be a lunar flyby. So you could go past the back of the moon. You could even go a little further than they went in Apollo, which that'd be kind of cool, I think.
I have one more question on pricing. Mike Leach is from Air and Space. A few weeks ago, Jim Mazur was addressing a group of journalists down the street at United Technologies, and he had very positive things to say about SpaceX, but he was talking about how expensive it was to get to orbit. And he said, I used to work at SpaceX, and
That's true.
He said they've doubled their prices since 2002. Is that true? And if it's true,
no, I don't think so.
True, is that what would he point to? He didn't elaborate.
Well, first of all, in 2002, we didn't even have any pricing because I only started the company in basically July of 2002. We didn't even know what rocket we were making in 2002. So it's not possible to have doubled from question mark. And I think if you look at the pricing for Falcon 9, ever since we rolled out the final specifications for Falcon 9, we've kept our pricing consistent at around the $50 million level. So I think we've been very, very solid in keeping our prices steady, and we do not expect to make price increases in the future except for inflation-related adjustments. In fact, over time, we really want to reduce the cost per pound to orbit because that is the fundamental gating factor that prevents humanity from becoming a true spacefaring civilization. It is just far too expensive to do space travel in the past, and so in order for us to have for the country to have and for humanity to have an exciting future in space, it is critical that we are constantly improving the cost per pound to orbit. And with Falcon Heavy, we're demonstrating that we are. Falcon Heavy is a significant improvement over Falcon 9 in the cost per pound to orbit, and it's right around the not so mythical anymore $1,000 per pound capability. And as we improve the performance of Falcon Heavy over time, we want to get it below 1,000 pounds. Yeah.
You have plans for something after this?
Yeah. Well, we have an idea for a super heavy lift capability that would be sort of on the order of 150 metric tons to orbit, so about 3 times the capability of Falcon Heavy. And that's something that we're working.
Bigger than a Saturn V.
That's 50% bigger than a Saturn V. Yeah. That's something that we're iterating with on NASA right now. NASA issued an RFP for design ideas on a Super Heavy. We were one of the companies that NASA awarded. It's a small contract of $300,000, but we're exploring with NASA how to do a 150 metric ton to orbit capability, but complete that development rapidly, and with an end result which is well under $1,000 per pound to orbit.
The trainmasters are agitating, so is there one final question in here?
Oh.
Go ahead.
Mr. Peter Palermo from FNU Services, and I wonder if you are confident that you could be the ones that replace the shuttle, and what would it mean for your company after all these shuttle?
Well, we're already slated to replace the shuttle as far as cargo transport to and from the space station, which is the main function of the space shuttle. Most of what the shuttle does is carry cargo to and from the space station, and of course it carries astronauts as well. If things go as we hope, in about 3 years we'll be launching astronauts to the space station. So then we will have replaced both the cargo and astronaut transport functions of the space shuttle. So we do expect that will occur. Now that's just slated to occur with Falcon 9 and our Dragon spacecraft. Falcon Heavy has potential to do a lot more than that.
In honor of our online...
Right, let's do one.
Final
Yeah.
online, and then
Mike Copeland from the Waco Tribune and Herald asks, what kind of work are we going to do in Texas with Falcon Heavy?
Sure. Well, Texas is where we do all of our engine development and stage testing. As I mentioned a moment ago, we've more than doubled the size of our property in Texas to now 600 acres. So we are expecting a significant workforce increase at our McGregor test site. I expect it to probably more than double over the next few years.
thank you all for coming. This conference will be posted on the National Press Club website for a few months. You will find a link to it on SpaceX.com. Thank you, Elon. Thank you all for coming. Thank you very much.
All right, thank you.